Good afternoon. Hello to one and all. Myself, Dr. J. Namrata Manohar, is back with an episode on embedded systems. Embedded systems is one of the latest technical subject topic which every engineer is interested with eagerness to know and master. This is because almost several electrical and electronic products are now being operated and controlled by an embedded system. Various devices, instruments, and gadgets in almost all areas of our walk of life as medical, telecommunication, commercial, aerospace, domestic, and military applications are now operating with an embedded system. To mention a few products, they are microwave ovens, electric cars, industrial robots, watches, and televisions. So now the question is, what is the approach to learn and master the knowledge of embedded systems? This episode presents the strategic approach to introduce oneself to the core elements of embedded systems. Before we begin, I would like to inform about the 5 videos I have made public so far, as they would also serve as a background for the present episode. So now our topic is the strategic approach to master embedded systems. Now, these are the 5 videos that I had already previously released. They are importance of programming for electrical engineers, computer programming for beginners, fundamental terms of computer programming, make research thrilling, and preliminary introduction to C programming language. Students may keep a notebook and a pen beside them so they can prepare their own notes. Now, first let us see what is an embedded system. An embedded system is an object, or the word, let us see the meaning of the word embedded. Embedded is an object being fixed in another object to make it look better and serve better. For example, a gemstone in a locket. So the embedded system we will be talking about is a combination of a hardware and software which is kept in any electrical or electronic device to increase its efficiency and operation. Now, first let us see what a subsystem is. A device, a component that has a particular function. Example, motherboard, fan, processor, etc. Motherboard, fan, processor, these are all subsystems which are kept within a computer system so that it completes the entire computer-based system. Now, a system is an interconnection of subsystems. The system performs a particular function. Example, computer system which is embedded with several subsystems. As we have seen above, the subsystems are motherboard, fan, and processor, which are assembled together in a sequential order so that the computer system will be able to perform the operation for which it is designed for. Now, what are the 2 embedded systems that we'll be discussing in this particular episode? They are microprocessor and microcontroller. A microprocessor is a CPU of a computer system. It is a small chip, hence it is called microprocessor. It consists of an arithmetical logical unit, ALU, and control unit, CU, necessary to perform the functions of a digital computer's central processing unit. It is mostly used for data processing. Here we can see an Intel Pentium 4 microprocessor. Now, what is a microcontroller? A microcontroller is a microcomputer control system consisting of CPU, memory, and programmable input-output peripherals. As the name indicates, it is used to control the operation of equipments and speed control of motor. The difference is microprocessor is mostly used for data processing. Microcontrollers are used for control operations. They are used to control motors. It could be a small motor, a large motor in industry. It can even be used to control the traffic lights. So here we can see the small chip Intel 8051 microcontroller. Now, the microprocessor or microcontroller has two major components, hardware and software. The hardware, we have to study the architecture and the building blocks, and the software, we should know the programming aspects and the language. Now, why I am saying it is a strategic approach. Strategic approach of learning embedded system is we should know what are the fundamental components of the microprocessor or microcontroller. So there are various types of microprocessors and microcontrollers. So fundamentally, we should know what is the hardware of that processor or controller and what is the software, what type of software you are using. Now, as regarding the software, the programming language, I've already started the episodes starting from my previous videos. In this, we will be seeing about the hardware aspects of the microprocessor and microcontroller. So whenever we are studying the hardware, we should know the architecture and the building blocks of that architecture for the processor or controller. Now, when we are studying the architecture, we need to have a foundation. That is, we need to know the history of the chip, why the chip was developed, where it was developed, who was developed, and for what purpose it was developed. So we need to know who invented it, which company invented it, why it was invented, where it was invented, what is the year of invention, and why it was named so. This is very important to know these aspects so that we have a good idea of that particular embedded system. Now, in our case, let us see the history of the microprocessor and microcontroller. Which company invented it? Microprocessor, Intel. Both of them were developed by Intel. Now, why was it invented? Microprocessor, it was invented to develop a semiconductor memory, calculators, and later it was used to develop the CPU, Central Processing Unit. In a microcontroller, it was ordered actually by a Japanese company, UCCOM, for calculators, for development of calculators and manufacture of calculators. But however, they found that the technology was suitable to use for control operations of various machines and devices and gadgets. So later, the contract was changed and it was sold as a general purpose microcontroller with success. So it can be used to control various devices and processes. Now, where it was invented? In US. Year of invention is microprocessor in 1970, microcontroller in 1971. Now, why it was named so? Micro is a short for microscopic and processor is the processing unit. So that's why it is called microprocessor. Now, microcontrollers are called so because they have an execution time in the order of a few microseconds or even nanoseconds. So that is why they are called as microcontrollers. Now, coming to the microcontroller architecture, which encompasses, you should study the pin diagram. You should study the central processing unit. What are the components of the central processing unit? The major components of any central processing unit are arithmetic unit, arithmetic logical unit, control unit, and the working storage registers. Then you need to know what are the various types of buses. You need to know the memory, the RAM, ROM, flash memory. Apart from this, any other memory provided in that particular architecture. Registers are also a type of memory, but very small in size. Timers, counters, interrupt handlers, and input-output peripherals. So we need to know how these things are provided, the provision made in the microprocessor and microcontroller to make use of these subsystems. Now, the pin diagram. We see the pin diagram of 8086 microprocessor at the left side and 8051 microcontroller at the right side. Both of them are having 40 pins. So we need to know how many pins they have. Then what are the various, what is the function of each pin? So here you see the microprocessor is having the address pins AD0 to AD14 and AD15. That means it is having 16 address pins. And Here they are using, these pins are being multiplexed. That is, some of the pins are used for address and some of the pins are used for data transfer. Now, in most of the chips, all chips compulsory will be having this ground. You need a voltage supply to operate the chip. Then you have other functionality. Based on the functionality, these pins are provided as ready, reset, lock, minimum and maximum modes, clock, and interrupt handling. For handling interrupts, we need to have this INTR. Then coming to the microcontrollers, as microcontrollers don't handle data, we do not have the data pins here, but these microcontrollers are connected to control any device, say a motor, or you may be wanting to control the lights, the sequential lights, like what we see in the functions where you get red, green, and yellow lights, which are operating in different sequence. Then here here we have this microcontroller 8051 has 4 ports. So say you want 8 lights, 8 small LEDs to be controlled. You can connect it to port 1, port 2, or port 3. So 8 of them can be connected to these 8 pins. So in this way, by connecting the device to any of these pins, we will be able to control. Traffic lights. The traffic lights, they are red, green, and yellow. So you can connect them to any one of the pins. Or you can even display the data as we see on the boards. You can also display the data by you connecting that particular LED and to this ports. So what are the various pins? Write, read, operation, then timer, timer where we need to connect the timers, how we need to connect the timers. So first we should know the various pins that are provided. Then we will be able to use the various options. Now, coming to the architecture of 8086. What is the architecture of 8086? The 8086 architecture consists of 3 major components: arithmetical logical unit, execution unit, and the bus interface unit. So as we said, the arithmetical logical units performs the arithmetical and logical operations. The there are 3 types of buses: control bus, data bus, and address bus. Address is used to transfer the address from between the control unit and the memory location, and you have the control unit which also sends the instructions or controls the operations of the various components on the embedded system chip. Now here we internally, as this system is something similar to our brain. Now as I am talking, you must be understanding and putting this data or information that I'm giving into your brain. Now, so here we need to have some temporary registers. What are the temporary registers? Here, this temporary registers will depend upon the architecture. In the case of 8086, it is a 16-bit microcontroller. 16-bit microcontroller means at a time, the data can be of 16 bits. So 16-bit data, it can handle at a time. So we have 4 general purpose registers: AX, BX, CX, and DX. So these are all each is 16-bit. But if you want, you can also access 8-bit, 8-bit. 8-bit lower part, AL, AH, BL, BH, CL, CH, DL, DH. So this is lower 8 bits, this is higher 8 bits. Then we also have what is called as a stack pointer, base pointer, source instruction, and destination index registers. Now, here bus interface unit, we have control segment. There are 4 segments: control segment, stack segments, data segment, and extra segment. And we also have a register for instruction pointer. Now, this bus interface unit is interconnected to the memory and input-output. Here you can see this is the bus which is connected, which is bidirectional. That is, the flow of signals is bidirectional between the bus interface unit and the execution unit. This 8086 microprocessor, in addition, has a 6-byte queue. Why is the 6-byte queue? Now you are having a program in your memory. The program is nothing but a sequence of instructions. So what we do is first you first the first instruction or the programming line. It is processed, that is compiled and decoded, and that instruction is kept in this Q1. Now here there are 3 stages: fetch, decode, and execute. There are 3 stages of any program line execution. So when the first instruction is fetched and then decoded, then the second instruction can be also fetched simultaneously. So these instructions are fetched from the memory and stored in this queue so that execution is very fast. It can increase the speed of execution. So what are these flags? The flag is also a single bit register, which gives the status of operation of the program. Operands are the data on which the processing is done. Say you want to add 2 numbers, the 2 numbers are called the operands here. Now coming to the 8051 architecture microcontroller, here you have the interrupt control, you have the central processing unit. 8051 has on-chip 4K byte ROM and 128-byte RAM. It has 2 timers, timer 0 and timer 1. It has a serial port, transmission and reading. Then input-output ports, as we have seen in the architecture, it has 4 ports, P0, P1, P2, and P3. They are connected to this port. And then you have the bus control unit here. And then the oscillator to give the signals for operation of the controller. Now, we need to know the central processing unit. What is the central processing unit? The central processing unit is the heart of the computer. So you can see the central processing unit consists of 3 major components: arithmetical logical unit, control unit, and memory unit. Between the memory unit and the arithmetical logical unit, the program instruction and data will be transferred. And between the control unit and ALU, control signals will be exchanged, right? So here you are giving in through the input device. It could be a keyboard or a joystick. You are giving, or it could be a CD. You are giving your input program. Whatever is it could be a program or data. Once you give the input, then the arithmetical logical unit, the control unit decides what operation is to be performed for each instruction, and then it sends the signals to the ALU and the memory unit so that the program is executed and you get the desired output. This is a look of a central processing unit, normally what we see now. So the central processing unit controls the flow of data and instructions to perform several tasks. It has 3 main components: arithmetical logical unit, control unit, and working storage area, which is a temporary storage area. That is, say you have a big expression. Now you have a very big expression, or you want to perform a large calculation. Now, before completing the total calculation, intermediate results you want to store. So you can store in this memory unit. And the final result, final executed result, final data can be stored in your RAM. Now, coming to the arithmetical logical unit, as I've told, it is performs arithmetical and logical operations using the various types of instructions as indicated in the architecture or the language which supports that particular architecture. Now, the various types of instructions available I've already covered in my previous video. So what are the signals that go to the arithmetical logical unit? The signals that are transferred are control signals as to what operation to perform, which arithmetical logical operation is to be performed. And then the operand registers, that is, what is the data on which this arithmetical logical operation is to be performed. Say you want to add 2 numbers, A and B. Then A and B are sent to the ALU. Now, the output result, after adding the 2 numbers, A plus B, you're getting the final result, which is stored in a register. Now, The other things are you get various types of flag. That is, suppose you are performing an arithmetic operation, there is a sequence of steps. We need to know what is the status of the execution at each instruction. So we have what is called as overflow flag, parity flag. So these flags indicate the status of execution of the program. So we will see what are these various types of flags in detail in the subsequent architecture. Now, coming to the control unit. The control unit, the inputs are the flags and the clock cycle. Now, the instruction register gives the various instructions and you get the control signals with the CPU here. The various types of registers in 8086 are A, B, C, and D. As we have seen in the architecture, AX, BX, CX, DX, they are all 16-bit. The other registers which support the operation and give the status of the programming are instruction pointer, program counter, process status word, stack AC, accumulator, AR, DR, and TR. Now, we'll see the interaction between the ALU and the CU and the memory, which is called as the machine cycle. Now, the first step is you fetch an instruction from the memory. You have stored your program in a memory at some location in the memory. So once you give the execute command, these instructions are fetched from the memory. Now, from the main memory. The first instruction, say we have 5 lines of programming. The first line is fetched, given to the control unit. So the control unit decodes the instruction into the command, and based on what is stated in that particular instruction, it gives signal to the arithmetical logical unit or the input-output device. Say you're saying you want to input the value of A and B, it will say input A. Then it gives a signal to the input device to accept the value of A. Then after accepting A and B, you want to add the two numbers that is sent to the A and B numbers are sent to the ALU, which execute the command, add the two numbers and give you the result. The output result can be stored either in the main memory or it can be displayed on the monitor or stored in any other memory location of the RAM. What are the various types of buses? The 3 types of buses are control bus, address bus, and data bus. So here you can see the bidirectional arrow indicate that there is a bidirectional transfer between the two devices. If there is a single direction arrow, that means only say CPU only can send the address onto the address bus. But CPU can send and receive the control signals through the control bus. Similarly, you have the data bus through which the data is transferred between the memory and the arithmetic and ALU unit. The input-output device. So input-output device, bidirectional, you have control signals to input, accept data from the input device or display your result on the output device. But the address bus, as you see, it is only unidirectional. And data bus again is bidirectional because you accept input from the input device and you can also display it on the output device. There are various devices which serve, there are some which serve only as input, some which serve only as output, some which serve input and output. Say a monitor serves both as an input and output device. So the 3 main buses are address bus. It allows the CPU to send the address to RAM to fetch the data at the specified location. The data bus, it transfers actual data from the memory to the CPU and input-output. Control bus, it transmits control signals between the memory and the input-output devices. Now, here, so what are the various types of memories? We have the permanent memory. We have the permanent memory and temporary memory. Normally, there are 2 types of memories, permanent memory and temporary memory. These memories come in different sizes. That is, how many bits or bytes or megabytes you can store in them. So the permanent memory is normally the ROM or read-only memory. This permanent memory is used to store system software which a user cannot change. Like this, any system you on your computer, default the computer should be on. It should display your Windows screen. It should allow you to create a file also. So that all this data in programming is stored in ROM, permanent memory. Temporary memory is called as random access memory. They are also flash memory, which is of high speed. Then you have various types of registers. These are all temporary memory where your intermediate results can be stored, or for some time you can store your final result. Now, or the type of memory, how to study about the memory. You need to know the size of the memory. What is the capacity of the memory? That is, how many bytes it can store. For example, 512 kilobytes, etc. So how do you calculate the capacity? Capacity is the number of memory locations into the bytes per location. So how many memory locations? So you have to know, and then you multiply it by the number of bytes per location. It will give you the capacity. Say the number of memory locations are 10 and the bytes per location is 16. That means 160 bytes you can store in that particular memory. Width. Width is number of bits per memory location. For one memory location, how many bits you can store. This is the memory. So the memory has a number of locations, sorry. The memory has a number of locations. The locations, sorry. These are the memory locations. So this memory location 0, 1, 2, 3, 4, it is stored. The width is how many bits it can store in one memory location. So here we have 1, 2, 3, 4, 5 locations, and each location is say of 8 bits. 8 5 are 40 bits. 40 bits you can store in this memory. So here this is how we need to know how to access the memory. Registers. Register is a small memory of limited size, right? The size could be 8-bit or 16-bit. 8086 has 16-bit, 8051 has 8-bit. Normally, the 4 types of registers in any architecture are general purpose registers, segment registers, special purpose register, and flag registers, right? Now, what are the various types of general purpose registers? What is their size will depend upon the architecture. It depends upon 8086 or 8085 or 8051. In 8086, you have AX, BX, CX, DX, A, B, and you have also have RX in case of 8051. The various segment registers are code segment, data segment, stack segment, and extra segment. Again, this is pertaining to 8086. So for that particular architecture which you are studying, you should know what are the various types of registers supported in that architecture so that it enables you to do your programming well. The special purpose register are a base pointer, instruction pointer, and stack pointer. Flag registers are control flag, and there are several other flags which we'll see in the subsequent slides. Now, every chip operates with a timing signal. So we have what is called as timers and counters. So a timer is a specialized type of clock which is used to measure time intervals. So it is a device that counts down from a specified time interval and used to generate a time delay. Suppose you want to perform an operation for 5 milliseconds. Then you configure the timer for 5 milliseconds based upon your clock signal. And then once it starts with 5 milliseconds, every tick, the 5 milliseconds keep coming down, 5, 4, 3, 2, 1. And when it comes 0, that particular operation stops. So on the contrary, counter is a device that stores the number of times a particular event or process occurred with respect to a clock signal. Say you want to count the number of times a motor has rotated, then you can use the counter signal. So it is used to count the events happening outside the microcontroller. So regarding this timer and counter, we should know what are the various registers that support the use of the timer and the counter. For example, TMOD, TCON, timer mode and timer configuration. So even for the counter, we should know what are the registers supported, what is the size of the registers we should know, and how to configure the register as a timer and a counter. What are the various mode of operation of the timer and counter we should study for that particular architecture. Now, we also have what is called as interrupt handler. Say a particular program is being executed, then in the meantime, there is another program which wants the services of the computer. Then we need to handle the interrupt. So an interrupt is an event or signal that requests the CPU's attention. So you may be asking, when a program is running, why should another program interrupt? But if we are not able to do this, then we will not be able to execute multiple programs at the same time. Like say in your computer, sometime you may be typing a documentation. At the same time, you may be giving an instruction to print another file, right? And you may be accepting an input or reading from a CD. All these are running in parallel. So when these are running in parallel, the two major resources of any computer system are memory and input-output devices and the control unit. So we need to have this interrupt handlers. So we know which program is to be given access to which of these particular resources in the computer. So interrupt handlers are also called as interrupt service routine. So how do we interrupt and how we can service is written in a particular program which is called as an interrupt service routine. So interrupt service routines are initiated by hardware interrupts or software interrupt instruction. Now, interrupt service routine is a piece of code that is executed for a specific interrupt. So for every type of interrupt, there is an interrupt service routine stored in a particular part of memory. So the various types of interrupts. So for every interrupt, the program is fixed. So once you give a particular interrupt, the control goes to the memory and fetches that program and executes that program. So interrupts are serviced based on priority. The input-output peripherals. A peripheral device is that which provide input and output for the computer. Some of the input-output devices work exclusively as input or exclusively as output or both input and output. So some of our input-output peripheral devices are keyboard and mouse, input to the computer, monitor and printer, which serve as an output, right? So input-output interface is used as a method which helps in transferring of information between the internal storage devices, that is memory, and the external peripheral devices. So we need to have an interface to interface the memory, the control unit, the arithmetical logical unit, the various registers on the chip, and your output device. So here we can see some of the input and output devices. The input devices are keyboard, optical pen, scanner, barcode reader, joystick, whereas output devices are headphones, headset, laser printers, plotters, screen, inkjet printers, and speakers. You have some set which both serve as input and output. They are digital cameras, pen drives, touchscreen, webcams, CD, DVDs, fax, and modem. So then we have this input-output peripheral interface. You can see how they are interfaced. You have the central processing unit and you have the memory. So we have the monitor, keyboard, and hard disk, which are interfaced to this address data and control buses through their respective interfaces. So thank you. If you have any more queries or you want any guidance, you can contact me on jnm7064@gmail.com. Please like and subscribe to my channel, and you may also give your comments. Thank you.